Newton's first law of motion states that every body continues in its state of rest or of in uniform motion until it is compelled to change that state of force impressed upon it. Simply means if a body is at rest, it will remain at rest until you don't apply a force. How will it move? It will move with a force. Uh, For that, we must know what is inertia. Inertia is the property of body due to which the body do not changes its state. Here state means rest or motion. Of course, mass is a measure of inertia. Inertia is of three types. First is inertia of rest. It is the resistance of a body to change its state of rest. There is an example when a train suddenly starts, the passenger sitting inside tends to fall backward because lower part of the body starts moving with train and upper part is still at rest due to inertia of rest. Second type is inertia of motion, the resistance of body to change its state of motion. For example, a body or a bus suddenly stops. Passengers sitting in it tend to fall forward because the lower part of the body comes to rest while upper part in motion. It is due to inertia of motion. And the third type is inertia of direction, the resistance of a body to change its direction of motion. A body will continue to move in the same straight line unless some external force tends to change its direction. For example, the mud coming from the wheels of a moving vehicle, they are flying off tangentially. Uh, the Newton's first law of motion is also called as law of inertia. So there are some other examples. Example is of hitting the mat to a wall because the mat is in motion but the dust particles are at rest. So that's why they fell down. They are separated from a dusty mat. A shaking branch of a tree. Of course, the fruits ripen and they will fall down because the fruits are at rest, whereas the branch of tree is in motion because the inertia given by you is that of motion to branch of tree, but we do not apply directly to force on fruit, so they remain at that point and then gravity pull down, that's why they fell down on the earth. Momentum is the quantity of motion. It's simply product of mass into velocity. It is a vector quantity. Its unit kilogram meter per second. Dimension formula mlt minus 1. Let us discuss now second law of motion. Second law of motion is that the change of motion is proportional to motive force impressed. In simple word, rate of change of momentum is directly proportional to the force. Newton's third law of motion. To every action, there is equal and opposite reaction. There are some things to be kept in mind for Newton's third law of motion, that there must be two bodies. There must be action acting on one body and reaction acting on the two body, and they must be in opposite direction, and they must be equal in magnitude. There are some examples. First is walking. You cannot walk without pushing the earth in backward direction. The horizontal component of the force makes you to move forward. It gives the acceleration in forward direction, and the vertical component balances you. But ultimately, you are pushing back Push means you are acting on the earth. Action is applied on the earth, and a reaction is acting on you. That's why you are moving in a forward direction and balancing your weight. Recoiling of a gun. As soon as the gun is fired, bullet goes forward, but the gun recoil backwards because the force which is given to bullet must be recoiled, means that force acting in opposite direction pulls the gun in backward direction. A man cannot swim if he do not push water in backward direction. By pushing the water in backward direction, the resultant is that the action acts on the body and the body moves in forward direction. Then the motion of rocket plane is also this example. The gases, the burnt gases, push the body in upward direction, push the rocket in upward direction. That's why the rocket moves in upward direction. It is a thrust of the gases which is pushing the rocket in upward direction. And if a man jumps out of a boat, then definitely the boat is pushed in backward direction because man is applying a force on boat to move in forward direction. You cannot drive a nail horizontally in a wooden block without help of the Newton's law of motion. Uh, there are some other examples. A boat is moved in shallow water of river with the help of long bamboo by pushing the bottom of the river backward by the bamboo. It's just again example like swimming. You push the bamboo in backward direction and you are sitting in the boat. It means you are pulling yourself in the forward direction. You are moving in forward direction. Of course, if a man is on a frictionless surface like ice, can get away from it by blowing air out of his mouth. Or if a man is in space, he wants to go back to his spaceship, he will throw the luggage in opposite direction where he wants to move. And of course, the hose pipe, the to extinguish the fire, the fireman direct a waterman on the fire from a hose pipe. This waterman exerts a reactory force on the hose pipe in the backward direction. This is the reason why firemen have to apply strong force on those pipes to prevent it from going backward. Let us discuss impulse. Impulse is the average force multiplied by the small interval of time from Newton's second law of his ma. So a is a acceleration, that is the rate of change of velocity, and this gives the mass into change in velocity, or the change in velocity is v final minus v initial. If we keep m inside, it becomes change in momentum because momentum is m mass into velocity. Okay, let us discuss some illustrations of impulse. For example, you want to take a catch. Definitely you will lower your hand. Why? Because you want to increase the reaction time. If you increase the reaction time, the impulsive force, the time of collision, the impact of the force will reduce. Hence, your hands are safe. Automobiles are provided with the spring-loaded system. I want to mention a very important thing that more time is given to reduce the impact, the force with which the bodies are striking. The spring is increasing the time and reducing the force of impact. And of course, there are so many examples like glass or ceramic plates are wrapped in a paper or straw pieces while packing. Why? Because during transportation, the package gets a jerk. The time of blow will be increased. This will reduce the force of blow. In this way, the glass of ceramic plate will be saved from damage because you have given a time. The time of collision is increased, hence the impact is reduced. A man falling from a height receives more injuries when he falls on cemented or pakka or marble floor because the time of collision is small. But if he fall on a heap of sand, then there will be large time and hence he will get less injuries. uh, it is difficult to catch a cricket ball as compared to tennis ball moving with the same velocity because the cricket ball is harder whereas tennis ball is softer, and that gives a spring action. A moving vehicle strikes against a fixed obstacle. A large amount of force acts on the vehicle. This is because the change in momentum is very large and is brought about in a very short interval of time. So, a large amount of force acts on the vehicle and the vehicle is damaged. And the vehicle is damaged. Well, it is very important that Newton's second law is the universal law or the real law because Newton's first law and third law are contained in the second law. How? Let us see. We know that from Newton's second law, F is equal to ma. If no external force acts, ma will be equal to 0. Mass cannot be equal to 0, so acceleration is 0 means either the body is at rest or is moving with the constant velocity. So it will not come to rest if it is moving with the uniform velocity, or it will not move if it is at rest because no external force is there. So this is the Newton's first law. Similarly, Newton's third law is also contained in the second law. Let us take an example of a table and a book. A book is lying on a table. Suppose there are two forces, F1, F2, acting on the table and the book. Let us say that forces are F1 plus F2. And of course, from the second law, F1 is dp1 by dt, rate of change of momentum, where p is the momentum, and F2 is also dp2 by dt. So F1 plus F2 is dp1 by dt plus dp2 by dt. Well, if they are not moving, the momentum is 0. And if momentum is 0, means p1 plus p2 is 0. So dt of p1 plus p2 is 0. So F1 will be equal to minus of F2. From where it comes from the second law. F is equal to dp by dt, rate of change of momentum is directly proportional to force, and that leads that third law is contained in the second law. So from here it is clear that Newton's second law is universal. Connected motion. What is connected motion? If two bodies are attached with each other and they are moving with the help of one another, then we call it as connected motion. Let us take an example of pulley problem, mass pulley problem. Consider a pulley that is massless and massless pulley, and of course it is a frictionless pulley. Massless pulley means its mass is very small and it has no friction. Two masses are attached on it with the string. Let us say m2 is greater than m1, so that's why m2 will fall downward, m1 will upward. So make free body diagram. Let us say for first, this is weight m1g downward and tension T upward, and the first body is going upward, so acceleration is in upward direction. So net force is mass into acceleration. So net force is T minus m1g. T is positive because A is in upward direction, and weight is negative because it is opposite to the acceleration. So T minus m1g is equal to m1a. And for second body, free body diagram, m2g minus t is equal to m2a because m2g is positive here because acceleration is in downward direction and tension is negative. So add these two equations, you will get the value of acceleration, and put the value of acceleration in any one of the equation 1 or 2 or divide them, you will get the value of the tension. Let us discuss one more example of Newton's third law. That is horse cart problem. Well, a horse is pushing the cart in forward direction. Horse is applying a force F on a ground. That's why he got a reaction R. Resolve R into two components, R cos theta, R sin theta. R cos theta component is in horizontal direction, which is responsible for the motion. This R cos theta is greater than the tension between the cart and the horse. Let us make free body diagram for horse and the cart. For horse, it is r cos theta, which is greater than t. That's why the horse will move. So r cos theta minus t is equal to m into a. R cos theta is positive because acceleration is in forward direction, and t is negative because it is opposite to the acceleration. This is equation number 1. And for cart, make a free body diagram. In this case, tension is greater than force of friction, because if tension is not greater, then how cart will be moving? So again, use net force is equal to mass into acceleration. T minus F is equal to m into a. T is positive in the direction of acceleration, F negative opposite to the direction of acceleration. So add these two equations, you will get the value of acceleration. There is a one. Let us discuss now circular motion. Consider a thread, consider a string, tie a stone with it, revolve in it vertical circle. At point A, it is the lowest point. The weight mg is in downward, and let its velocity is v1 at this point, and tension t1 is towards the center. While a1 is the centripetal acceleration that is acting towards the center. And when it goes to the upper point B, mg is the mass, t2 is the tension, a2 is the centripetal acceleration towards the center, and velocity v2 along with which it is moving at the highest point. So make free body diagram for highest point and lowest point. First, for lowest point, so use this formula again. Net force is equal to mass into acceleration. T1 minus mg is equal to mv1 square by r. And for free body diagram for the highest point, it is T2 plus mg is equal to mv2 square by r. T2 and mg both are positive because they are in the direction of acceleration, where in this case mg was negative in equation number 1. Again, just simply add these two equations. Let us say the body just reaches to the highest point. Assume tension at this point is 0 because it just completes a circle. So from equation 2, we will get v2 is equal to rg under root. This is the minimum velocity required at the upper point to complete the circle. But this velocity must be given at the lowest point. So use law of conservation of energy for lowest and highest point. At the lowest point, it is only the kinetic energy, half mv1 square. And at highest point, it is the kinetic energy and potential energy, because at highest point, kinetic energy is reduced and that is converted to potential energy, and H is equal to 2R. Put the value of V2 under root Rg. You will get the value of V1 equal to 5 Rg under root. So this is the minimum velocity required to be given at the lowest point to complete one circle. Well, from 1 and 2 equations, subtract these equations, put the value V1, V2, you will get the difference of tension equal to 6 times the weight. So be careful that a thread or string which you have chosen must bear the tension equal to 6 times that of its weight. V1, V2 is dependent on radius but independent of the mass, and T1, T2 is independent of the radius. Bending of cyclists. It is the example of the centripetal force. If you are providing centripetal force, necessary centripetal force, then and then only a cyclist can bend. Suppose this is a diagram of a cyclist. I have made a free body diagram. Resolve r into two components, r cos theta, r sin theta. R cos theta is balanced by the weight mg and r sin theta is balanced by the centripetal acceleration. So from these two equations you will get the value of velocity, that is equal to under root rt tangent theta. This is the safe speed with which a cyclist must move on a track that is circular track, banking up of roads. If it is a car, then the car cannot bend, but we can bank up a road. And let us say that banking up of road is again an angle theta. Again resolve the components. Again resolve r into two components, normal reaction into r cos theta, r sin theta. And r cos theta is weight, r sin theta is mv square by r. So you will get tangent theta is equal to v square by r. This theta is the angle of banking up of roads. So find out the velocity which is required, the radius of the path, and then you will balance this equation. Coefficient of friction. Friction is a necessary because to apply brake, or you can say if a body stops, then it is due to the friction. The most important is angle of friction. Let us discuss first of all the angle of friction. See, if a body is moving in the forward direction, a friction force will act in opposite direction. In normal reaction, R is acting, and let us have resultant of normal reaction and force of friction, and that is equal to R1. So now the angle between R1 and R is called angle of friction. And let me define now force of friction. Dear friends, force of friction is directly proportional to normal reaction. And the constant of proportionality mu is the coefficient of friction, which has no units, no dimension formula, because it is the ratio of force of friction to the normal reaction. So mu determines whether the surface is rough or smooth. So more be the value of mu, more it has friction. Well, we can find out the alpha. Let us discuss again the angle of friction. I have defined you that this alpha between the the normal reaction and resultant is the angle of friction. Now forget about the normal reaction, just resolve R1, that is a resultant, into two components, r cos theta, r cos alpha, and r sin alpha, where alpha is the angle of friction. We know that from this free body diagram, r1 sin alpha is f and r1 cos alpha is mg. So divide, you will get the tangent alpha is f by r, because this r1 will cancel and tangent alpha is f by r. So this is the relation between the coefficient of friction and the angle of friction. Let us define now angle of repose. See, an angle theta. We have now a plane that is banked up at an angle theta. So this theta is the coefficient. This theta is the angle of repose. But when this angle theta becomes repose when the body just begins to slide down. Okay, so let us find the relation between theta and alpha, means the angle of repose and the angle of friction. Make a free body diagram. This is the normal reaction. Suppose the body is moving in downward direction, friction upward, weight downward. This time let us resolve the two components of weight, one along theta, that is mg cos theta, and second is mg sin theta. Now balance these two components, means r will be equal to mg cos theta and f will be equal to mg sin theta. Of course, we will divide. Mg will get cancelled. Be careful in resolving the vector. For in earlier article we have resolved the resultant, and now we have resolved the weight. It depends upon the requirement. So from here, mu is equal to tangent theta. Oh, we have also obtained that alpha is equal to tangent inverse mu. So of course theta is tangent inverse mu. So simply theta is alpha, means the angle of repose is angle of friction. Now let us find the expression for the acceleration of a body sliding down a rough inclined plane. I have considered a body moving down an inclined plane at an angle theta, weight mg, resolve it into two components, mg cos theta, mg sin theta. Have a free body diagram. From this equation, C F R mg sin theta, mg cos theta. But in last article, we didn't considered the acceleration. Now we are considering the acceleration. So the equations will change. So from here it is clear that normal reaction is balancing the component of the weight, that is r is equal to mg cos theta. But here I have applied net force is equal to mass into acceleration. So mg sin theta is positive and f is negative. So mg sin theta minus f is equal to ma, and f is mu r. And what is r? Mg cos theta. Put the value of r here, and then you will get the value of acceleration, that is g sin theta minus g mu cos theta. This is the acceleration down the inclined plane for a body. Okay. Well, can we reduce friction? Yes, of course. Polishing. When you polish the surface becomes smooth. The coefficient of friction will reduce, and this will overcome the friction. Unevenness of surface is reduced now, and polished tubes are used in watches to hold axle between them. The same can be achieved by rubbing the surfaces with sandpaper. During whitewash you might have seen this. Lubricating. Of course, we can apply some lubricants and grease and solid, these are the semi liquids. And whenever you apply lubricants, then of course, there's one example of carom board. When you apply you throw some powder on it, what happens? So the friction reduces, of course. And the last one is, using ball bearings. Always keep in mind that rolling friction is always less than the sliding friction, and for rolling friction what we require ball bearings. Okay. Is friction necessary? Yes, it is necessary evil. Why? Friction is wasting the energy. No. Yes, of course it is dangerous, but of course it is helpful. Why? Because if you want to walk, what will you do? You will push the earth, and suppose if there's no friction, then you will fall down. Okay, so for applying brakes you require friction. Rolling down on an inclined plane is due to friction. There are so many examples which indicates that friction is necessary also. Thank you.